Hi, my name is Gabriel Conrad and I'm doing my STEM project presentation. Were planes tested by falling? You may not think so, but that is how I tested my airfoils or plane wings. Drag is one of the four fundamental forces of flight. There are four factors involving drag. The first one is the most prevalent: shape. If I were to have two objects, a cube or a cylinder, the cylinder would fall faster because it is a more defined shape, a more refined shape. The second factor is size or surface area. You can see this demonstrated in our practical application of parachutes. If the surface area of the parachute slows it down because it has a high surface area when the object is falling. The third factor is speed. Objects that have a higher speed have higher drag. If the object is going 10 miles an hour versus an object going 1,000 miles an hour, the faster object would have more drag. The last factor is density. An object that has more density will fall faster. You may be wondering, why don't we just make small planes that are needle-like planes? This is because of another force of flight called lift. Lift is essentially the force that makes a plane go up. The airfoil that achieves lift and has a low drag is a streamlined airfoil. My problem is, does a streamlined, blunt, or curved airfoil best decrease drag? My hypothesis is that the streamlined airfoil will decrease drag the most. The hypothesis criteria is, of course, that the streamlined airfoil will be the fastest, and the streamlined airfoil, or the second fastest airfoil, will be slower by at least 0.1 seconds than the streamlined airfoil. The variables are, the first one is the independent variable, which are the three types of airfoils: the streamlined, blunt, or curved. The second variables are the dependent variables, which is the time taken for the airfoils to fall, and the controlled variables, which there are many of them, but a couple are the height of the ceiling, the location, and the weight of each airfoil. There are 5 trials that were conducted. Some of the materials that were needed for this experiment were paper, scissors, a stopwatch, and tape. The experimental procedure is as follows. I used paper, scissors, and staples to make each airfoil: the streamlined, blunt, and curved. I only made one of them, and I used marker to identify each of them so that I would not forget. I chose a location, that stairwell right there, and the experimental procedure was I held each airfoil so that the thick edge or the leading edge was facing the floor, and the trailing edge or the thin edge was facing the ceiling. In my left hand I held my stopwatch, and in my right hand I held the airfoil. At the same time that I let go of the airfoil, I also pressed the stopwatch. And once I let go of the airfoil and I saw that the airfoil had hit the floor, I stopped the stopwatch. I redid each test if there was an interference, like the airfoil did a flip, or something hit the airfoil, or it ran into a wall, things like that. I repeated this until all the airfoils were dropped. That was one trial. I performed 5 of those. The results are as follows. The streamlined airfoil had the fastest average fall time. The average streamlined airfoil fall time was 1.6 seconds. The curved was 1.7 seconds, and the blunt was 1.8 seconds. The fall time over the 5 trials was not consistent, indicating an unknown variable. There are some graphs here. This one is the average fall time, and this one is the fall time over the 5 trials. In conclusion, the hypothesis was accepted because the streamlined airfoil had the fastest fall time, and the second fastest airfoil was slower on average by at least 0.1 seconds. The fall times fluctuated, but that is not exactly important because it was an average. The testing was on average. Some limitations are as follows. Sometimes the airfoils would flip and thus taking more time to fall. The designs are my interpretation of what they are, of what the airfoils are. In the future, there might be some different alterations, and this is not a real test. The airfoils are made of paper and staples. A real plane would most likely be made of aluminum, and therefore having other factors determining their outcome. This was done to see which airfoil falled the fastest. In real life, you don't really want an airplane to fall because airplanes are going horizontal. There are also other factors you need to consider. Future studies are for this project. You could have an RC car, and you could attach different paper or cloth parachutes to it, and you could have a fan, and you could remotely control the car to the fan and at the same speed as others. You could drive the car into the fan and see how long it takes to do that, and then repeat it with different types of parachutes. You could also drop different types of parachutes and see which type fell down the fastest or the slowest. And yeah, that's my STEM project.
I feel the need for speed. It's aviation time with Mr. Gabriel Conrad.